Hi there, welcome to Sarispa. Today we'll be diving into some hard SAT math problems. For those of you taking the August SAT, good luck. Let's go ahead and get started. Okay, so starting off strong with this system of equations we have here, P is a constant, and if the system has no solution, what is the value of P? So there are two ways I'm going to go through this. First one is going to be the long way, and the second one is going to be the shortcut. So let's go ahead and get started with the long way to see how exactly this works. So what I'm going to do is I'm going to put each of these in standard form. So that'll give me negative 5 eighths x, and then I'm going to bring the 7 eighths over, so plus 14 eighths y equals 4 sevenths. And then on the bottom here, I have 5 fourths x minus py equals 8 fourths, which is just 2. Okay, so now we'll see why I'm doing this, but I want both of the coefficients of x to be the same. And so all I'm going to do is I'm going to multiply this bottom one here by negative 1/2. So that will give me negative 5 eighths x plus 1/2 py equals negative 1. Okay, so for the lines to be parallel, and for the coefficients of x and y of one equation to be proportional to the coefficients of x and y for the other equation, we're going to have to make these coefficients, the y coefficients, to be equal as well. And the way we're going to do that is just let them equal to each other. So 14 eighths equals 1/2 p. And then I can see that p has to equal 28 eighths, which is the same thing as 7 halves, or 3.5, which is our final answer for p. So that's the value of p we need for the system to have no solution. Okay, and then as I said earlier, let's go ahead and take a look at this in Desmos for the shortcut. And so I basically put the system of equations into here. Now I'm going to go ahead and add a slider for p. And I'm just going to change this until I can get both of the lines to be parallel to each other. And I kept moving them until I got to a spot where I was pretty confident. Now, like, if we were to take the wrong answer here, like if we were to take 3.7, you could see that obviously at some point it's going to intersect, which is not what we want. So if I actually get it to be right where it's supposed to be, no matter how long you go, there is not going to be an intersection. These are going to be parallel, no solution. So that's a quick shortcut to do it in just seconds compared to the route I showed you, but it's a good idea to do the long way sometimes, only if you have time, especially if it's the first module and you've got some time left over, so that way you could be 100% sure. So hopefully this shortcut helps as well. Okay, so this is actually a pretty easy problem once you understand how to approach it. So we know that a linear equation looks like y equals mx plus b. So since we already have the coordinate 3, 7, let's go ahead and plug that in to find b, because we also get the slope as well. So 7 equals 2 times 3 plus b. So I subtract 6 on both sides. I know that b is 1. And now I have the equation I need. So y equals 2x plus 1. And it's just a matter of finding k and n. So let's go ahead and do that. So if I had k 11, I know that 11 is going to equal 2k plus 1. So 2k equals 10, so k equals 5. And then for the other one, I know that n is going to equal 2 times 12 plus 1. Again, this is literally just plugging in. And n equals 25. And then when I do k plus n, that is 25 plus 5, and that is going to give me 30. All right, so moving on to the next question. What I really like about this question is I've seen it pop up a couple times on practice tests. And so once you understand the concept, you can apply it to different places. So, the results of two random samples of votes for a proposition are shown above. The samples were selected from the same population and the margins of error were calculated using the same method. Which of the following is the most appropriate reason that the margin of error for sample A is greater than the margin of error for sample B? Sample A had a smaller number of votes that could not be recorded. No, that doesn't make sense. Sample A had a higher percent of favorable responses. No, I don't see how that could affect the margin of error. Okay, now C and D, I see they're talking about sample size, and sample size can actually affect the margin of error. So let's figure out which one of the two it is. So, sample A had a larger sample size, and sample A had a smaller sample size. So, if we're saying that sample A had a greater margin of error compared to sample B, it would make sense that that one had a smaller sample size, that A had a smaller sample size because it may be less representative of the entire population we have there. So that means D is our final answer. In the given equation, k is a constant. The equation has exactly one real solution. What is the minimum possible value of 4k? So we're going to go ahead and take this to Desmos to see how we can find the answer. Okay, so what I did here is that I have square root of k minus x, and then I have 58 minus x, and I'm trying to figure out where they intersect. And in order to do so, let me first add a slider for k so that we can see that. And I'm just going to move it, and I can see obviously this is not going to be enough, so let's just change this to a bigger number. Keep moving it, boom. And now I can finally get them to intersect. So we want the minimum possible value. So I'm going to have to move back a little bit. Let's see. Okay, so, and let me also have 4k here in the corner so I can see what the values look like for the minimum possible value. So, this here at first glance might seem like the right answer. Look, I mean, it's here, it's intersecting there, so obviously I'm done. No, this is actually a pretty tricky question here because that's not the first place where it intersects. You can actually, it's going to have to move in a little bit more. So we're going to actually change that manually. So if I were to keep changing this, okay, 57.5 won't work. So let me try 57.75. That works. I have an intersection right there. So that's actually where my first intersection is at. So be careful, because now we see that the minimum value of 4k is actually 231. That's our final answer. And hopefully you enjoyed these hard SAT math problems. If you want to see more, please subscribe. Thank you.